In this video, we're going to discuss the concept of the molar mass. The molar mass of an element or compound is defined as the mass in grams of 1 mole of that element or compound. Now let's briefly review the concept of the mole. A mole is a collection of atoms, molecules, or formula units, and 1 mole is numerically equal to 6.022 times 10 to the 23rd atoms or molecules or formula units. So if we said we had 1 mole of carbon, 1 mole of sodium, 1 mole of gold, 1 mole of lead, we would have the same number of atoms because 1 mole of anything is 6.022 times 10 to the 23rd of that substance. Now, although we would have the same number of atoms, the masses of 1 mole of those elements would be different. So for example, a mole of carbon has this many atoms, but has a mass of 12.011 grams. A mole of sodium, we have the same number of atoms, but it has a different mass, 22.990 grams. So these have, we would say, different molar masses. The molar mass is the mass of 1 mole of a substance. And of course, the masses are different because the size or mass of the atoms are different. Sodium has more protons and neutrons. A sodium atom has more protons and neutrons than a carbon atom, so it has a heavier mass and therefore a heavier molar mass. So kind of a silly example to illustrate that would be, let's say we had 1 mole of elephants and 1 mole of mice. Well, we have 1 mole of each, so we have the same number of elephants and the same number of mice. However, 1 mole of elephants has a much greater mass than a mole of mice. So the elephants have a greater molar mass than the mice. So we could have the same number of elements, but their molar masses are different. So how can we determine what the molar mass of an element is? Well, to do that, we simply look on our periodic table. The molar mass of an element in grams is numerically equal to the element's atomic mass in AMUs. So remember, previously we said that on our periodic table, the atomic mass appears on our periodic table for each element, and the atomic mass of hydrogen is 1.0079. So one hydrogen atom has a mass of 1.0079 AMUs. Well, we could say then one hydrogen atom has an atomic mass of 1.0079 AMUs. 1 mole of hydrogen atoms has a mass of 1.0079 grams. So this number on the periodic table represents the atomic mass in AMUs and the molar mass in grams. So we could say the molar mass of hydrogen is 1.0079 grams per 1 mole. Carbon atom is 12.011 AMUs. A mole of carbon atoms, so 6.022 times 10 to the 23rd carbon atoms, has a mass of 12.011 grams. We would say the molar mass of carbon, therefore, is 12.011 grams per mole. And we could say the same thing for any element, like uranium. So we simply need to look on our periodic table, and we could find what we know to be the atomic mass, and now the molar mass is numerically equal to that. But the units for molar mass, as we'll see, is grams per mole. So the molar mass of an element or compound is defined as the mass in grams of 1 mole of an element or compound. And so therefore, the units for molar mass are grams per mole, the mass per 1 mole. And we could write that, say this is carbon, we could write the molar mass for carbon as 12.011 grams per mole. But as we'll see later, we often want to do dimensional analysis problems involving molar masses. So we could write it as a conversion factor. For carbon, 12.011 grams per 1 mole of carbon, or we could reverse that, of course, and put the moles and grams on moles on top, grams on the bottom. That's for carbon. We could do the same for magnesium. Write it like this, or if we're doing dimensional analysis problems, which we'll do later, we'll write it either way. Now, Often, chemists need to know the molar masses for compounds. We saw for elements, we can just get them off the periodic table. How would we figure out the molar mass for a compound like sodium chloride? Well, we know that 1 mole of sodium chloride, if we had a mole of sodium chloride formula units, we have 1 mole of sodium atom and 1 mole of chlorine atoms. So to figure out the molar mass of this compound, the molar mass is equivalent to the sum of the molar masses of the atoms that compose it. So for sodium chloride, we get off our periodic table, we see the molar mass for sodium is 22.990. The molar mass for 1 mole of chlorine is 35.453. Again, we got these off the periodic table. We simply add them together, and now we have the molar mass for sodium chloride. Let's look at one other one. Let's take a look at water. Figure out the molar mass for water. Each mole of water contains 2 moles of hydrogen atoms and 1 mole of oxygen atoms. So the molar mass again is equal to the sum of the molar masses of the atoms or elements that compose it. So for hydrogen, a hydrogen atom has a molar mass of 1.0079. Water contains 2 moles of that. So we multiply the molar mass of hydrogen times 2, and oxygen has a molar mass of 15.999 grams from the periodic table, and 1 mole times 1 mole of that. So we add these two together to get the molar mass 2 moles of hydrogen, 1 mole of oxygen, and we get the molar mass for water as 18.015 grams per mole. Now again, anytime we do a calculation, be sure to watch your sig figs. So let's have you try one. Calculate the molar mass for formaldehyde. Get a periodic table to help you with this. Pause the video and give it a try. So formaldehyde is composed of one mole of formaldehyde, composed of 1 mole of carbon, 2 moles of hydrogen, and 1 mole of oxygen. So we take the molar mass of carbon times 1 mole, molar mass of hydrogen times 2 moles, and the molar mass of oxygen times 1 mole. Again, we get these values from the periodic table, these values from the chemical formula, and then we multiply those, and then we add them together to get the total molar mass. So 1 mole of formaldehyde has a mass of 30.026 grams. Try one last one. Calculate the molar mass for calcium nitrate. Pause the video, use your periodic table, and solve this problem. So calcium nitrate, 1 mole of calcium nitrate is composed of 1 mole of calcium, 2 moles of nitrogen, so 2 moles of nitrogen, and 2 times 3, we have 6 moles of oxygen. So we take calcium's molar mass times 1, nitrogen's molar mass times 2, and oxygen's molar mass times 6. Add those together to get the molar mass for calcium nitrate. So be sure you understand the concept of molar mass, and you can calculate the molar mass for any element or compound.